Hi guys, today we are going to do a very interesting and important question from the chapter Continuity. This question is taken from Miscellaneous Exercise 1 of chapter Continuity from 12th standard. The question has f of x defined as 1 upon 1 plus e raised to 1 by x. The power is also in reciprocal for x not equal to 0, and the function is defined as 0 when x is equal to 0. So they have given us this at the point value, and they have given us this limit value, which is 1 upon 1 plus e raised to 1 by x. We have to check whether the function is continuous or not. In such questions, how are we supposed to proceed? So fx is given as 1 upon 1 plus e raised to 1 by x for x not equal to 0. In such questions, you have to consider LHL and RHL and check whether the values are equal from both sides. So first of all, I will consider LHL. In LHL, the value of x will not be equal to 0, but it will be very close to 0 and approaching 0 from the left hand side. So we can say that this limit is approaching x from 0 but from left hand side. So it will be a very small but a negative number. Now we need to understand how this will react. So if I say that the number is very small and negative, I can say x is minus 0.0001. Now imagine 1 upon minus 0.0001. Obviously it will be a very big number, and we can say this is minus 10,000. But this number, as it is approaching 0, can be taken as approximately minus 0.000000 and 1. So the 1 upon x value will nearly approach minus infinity. This number will go on increasing. So as we know, 1 upon x will tend to minus infinity. So we have our function f of x as 1 upon 1 plus e raised to 1 by x for limit x tends to 0 minus. We can say the limit is 1 upon 1 plus e raised to minus infinity. So our LHL will be 1 upon 1 plus 1 upon e raised to infinity, which is nothing but 1 upon 1 plus 0, which will be equal to 1. Hence our LHL value is actually equal to 1. How did we get it as 1? Because 1 upon x was minus infinity. So e raised to minus infinity is nothing but 1 upon e raised to infinity. But 1 upon e raised to infinity is 1 upon infinity, and 1 upon infinity is nothing but 0. Hence the LHL is 1. Now let us try and calculate the RHL. So limit x tends to 0 plus 1 upon 1 plus e raised to 1 by x. Now as x tends to 0 plus 1 upon x will tend to infinity, and which will be positive infinity. So our function will change to 1 upon 1 plus e raised to infinity, which will be equal to 1 upon 1 plus infinity. 1 plus infinity will be nothing but infinity, and your answer will be 0. Therefore your RHL is actually equal to 0. So till now we have LHL as 1 and RHL as 0, and they had also given us f of 0 to be 0. So we can say that f of 0 is equal to 0. As we can see, LHL is not equal to RHL, left hand limit is not equal to right hand limit, therefore f of x is not continuous at x equal to 0. Now, as we have already seen that what is meant by continuous function. So let us see, if you are able to draw a graph without lifting your hand, then it can be termed as continuous. So this particular graph is termed as continuous everywhere. But if I have some graph like this, in which I have to lift my hand and then draw the curve, then you see over here at this particular point I had to lift my hand, therefore at this point the function is not continuous. So as we have now solved a particular question concerning 1 upon 1 plus e raised to 1 by x, I would like you to have a look at the graph. Now this graph is made by a simulator for 1 upon 1 plus e raised to 1 by x. Now at x equal to 0, as you can see, to the RHL the value is 0 or very close to 0, but to the LHL you can see the value is 1 or very close to 1. Hence, while drawing this graph of 1 upon 1 plus e raised to 1 by x, I had to lift my pen at x equal to 0, keep it down, move it to 0, and again I make the graph. So I had to lift my pen at x equal to 0. Hence the function is discontinuous at x equal to 0. Thank you for watching the video, guys.